Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Rosenwald here with notes today. We're going to be working on section 4.2 notes. And this section has to do, again, with dealing with sinusoidal functions. And we're talking about all the different shifts that take place, whether it's stretches and shrinks, reflections, whether they're vertical or horizontal, periods of the actual function itself, and like how to change it into different intervals so we can get all the different values that go into the period of it. Any phase shifts left and right, and then any up and down motions, vertical translations. So this is a big equation that we're going to be talking about here, and that equation is this right here. Okay, and this is going to be the same for sine and cosine, where we have four different letters that are taking place. If we recall, the A value causes that vertical stretch or shrink to be taking place. If it's negative, it causes a reflection over the vertical direction, which is in the over the x-axis. Excuse me. If we have a B value here, remember that this is going to cause a horizontal stretch or a shrink to take place, a stretch or a compression. And the C value here causes our graph to be left or right, and the D value causes our graph to move up or down. It is important to note, especially in this section, that you'll notice the B value in these is always going to be factored out. And you'll notice here that in the front of this X is always a 1. So that means if there's ever a number attached to your X, you have to take that X value and get it away from the B value by factoring out. So we're going to talk about how to actually handle those today in these problems, all right? We have a handful that we're going to get through. We're going to dive right in because this is just a continuation of what we did last time. So let's get started. So looking at our first problem here, let's talk about all the transformations that we actually see taking place in this. The first thing we see is that there's a negative value right here, which means that we're going to have a reflection. We have a 2 in front of this, which tells us that there's going to be a vertical stretch taking place. And we see a -1 that's outside of the parentheses, not in the inside. And because it's outside, we're going to have that up or down shift. In this case, it's going to be down 1. So that negative in front of my function tells us, again, that's going to be reflected over x. The 2 that's in front of it says we're going to get a vertical stretch by 2. And the -1 after the x there, outside the parentheses, tells us that the graph is going to actually be shifting down 1. So the vertical shift, when we look at this, let's start naming the letters. The D value in this is -1, okay? And what happens is the graph goes down 1. I'm going to ask you guys to start kind of listing out the A, B, C's, and D's, because when we start doing word problems with these, it's important that we can recognize and identify A, B, C, and D in order to write the function of a word problem, okay? For the amplitude, we look at the A value. That's that value that's in front of here, and we know it's a -2, so the absolute value of -2 is 2. So the amplitude for this is simply 2. And remember, the amplitude tells us how far up from the middle it goes and how far down from the middle it goes. We're going to go 2 up and 2 down. For the horizontal shift, there is no shift. There's nothing attached to my x here that's causing it to go to the left or right, so the C value is equal to 0. So there's none. For the period of this, the B value here is equal to a 1. There is a 1 attached to my x right here, and so it's just 1, which means that when we look at our period, if you remember, the formula is 2 pi divided by b, and in this case, my b value is equal to 1. So the period for this is that the whole sinusoidal function is going to take place over 2 pi. Now, in order to get the interval that we're going to be increasing by as we move along the axis here, we're going to be taking 2 pi and breaking it into 4 equal parts. So we take the 2 pi, break it into 4 equal parts, do 2 pi divided by 4, and remember this means we're incrementally increasing by pi over 2. That's just 1/2, because 2 over 4 is 1/2. So now let's put all this stuff together into our actual picture. Now, from last time, you guys had graphs where we were only focused on the right side. From here on out, I actually am going to be drawing the right side and the left side, because we might have problems where you'll see points that might start over here and they end up getting reflected over to the other side. So I like to actually have it where I've got the right side and the left side, okay? Let's start first. We always talked about this, that the process you go through in doing these is you always do reflections before you do any movements. You reflect on things before you act on things, okay? That's how we handle movements. So let's deal with all this stuff on the y-axis first, and we'll deal with reflections and movements and all that stuff. We'll get our picture, don't worry, all right? So my graph has been shifted down 1, Okay, it's been down 1. That means that instead of us having a 0 right here, we're down 1 at -1. The amplitude for this is equal to 2. So what that tells us is that we go up 2 from this to get to the upper value, the max, which means -1 plus 2 puts us at a +1. To go down 2 in the other direction, so it's 2 up and 2 down, -1 minus the 2 that's there means we're going to be at -3 for the minimum. Okay. So far we've taken care of the down. We've taken care of the amplitude up to and down to. Let's talk about where we're going to actually start. The graph is not shifted to the left or right at all. And so that means that we're going to be starting at a 0 right here. And from there, we're going to incrementally increase for the interval by pi over 2. So we'll go 1 pi over 2, and then another, and then another, and another. And we've got 4 separate spots here where it increases for a total of 5 different points. And these are those points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, we're starting at 0 and going up by pi over 2, go up by pi over 2, up by pi over 2, and up by pi over 2. We've got everything. We've got all of our stuff taken care of, except we have one more thing we have to deal with, which is our reflection that's going to take place. Now let's get our points in here first, okay? Since it's sine, we know that we're going to have a point here, and the bottom, the middle, the bottom, and then back to the middle. Now we're going to take each one of these points and we're going to do the reflection that we said is going to take place. Okay? So if I took this point right here and I reflected it, it's not going to move. It stays exactly where it is. Okay? If I take this point right here and I reflect it, what's going to happen is that point that's right there is going to move down to the other side, and we will no longer have this point up here. Instead, the point's going to be down here. Okay? If I take this point and I reflect it, what's going to happen is it's going to stay exactly where it is and won't move, so we don't touch that. If I took this point and reflected it over x, what's going to happen is it's going to go up over here and be reflected to this spot now, and that one is no longer used. Okay? And then again, that middle point that's right here, if I took that middle one right here and I reflected it, it's not going to move. So what's going to happen is my curve is now going to look like this. It's been reflected over from its normal position. That's all of it. All right, let's keep going. We're going to go a little bit faster on this one. Okay? Let's talk about each one of the transformations first. 1/3 in front of my function tells us that we have a vertical shrink by 1/3. The 4 that's right here tells us that we're going to have a horizontal change take place, and it's going to be a horizontal shrink by 1/4. Remember, shrinks in the horizontal direction and stretches in the horizontal direction are always the reciprocal effect. Okay? And then because we have a +2 here, my graph is going to be shifted up 2. So the vertical shift up 2 is our D value. It's +2. The amplitude is equal to 1/3. That's my A value is 1/3. The horizontal shift is that it doesn't move left or right, so we don't have to worry about that left or right shift. The period for this is equal to 4 for the B value. The B value is 4. So we got to work with this. We have a horizontal shift taking place, a shrink in this case of 1/4. So that's going to change my period. So if we look at the 2 pi over B, because our period is normally 2 pi, we're going to put it over the B value, which is 4. If I take and I simplify this fraction, this 2 pi over 4, that's going to equaling pi over 2, or just 1/2, because 2 over 4 is just 1/2. So now my period, instead of it taking 2 pi to get through the entire period, now it's only going to take pi over 2 to get through the period. All right, let's see this in action here. So when I look at this picture here, all right, and we talk about the sinusoidal function, when we look at the original parent function here, okay, we've got a B value that's equal to 1 on the, on the original function, that green one that's right there, the B value is equal to 1. Well, what happens when I change my B value to a 4? Watch what happens here. I'm going to take it and move it to a 4, and you can see it's getting absolutely smushed into here. And what we see now is that it takes 1/4 as long. So in order to get through an entire wave here, it goes from 0 all the way up to, so you can see right here, it goes from 0 all the way through a wave, and it stops right here at 1.57, which is half of pi. Okay? And then, so there's that period. Now it's half of pi. we're going to take this and break it into 4 separate increments like we always do. Pi over 2 divided by 4 means we end up with 1/8 for the intervals. So let's put this all together into our picture. Okay. My graph shifted up 2. That means that because it shifted up 2, this value is now going to be shifted up 2. So now it's going to be a positive 2. The amplitude for this is 1/3. So that means we're going to go up 1/3. And that means we're going to be at 2 and 1/3. And I also go down 1/3, which means I take 2 and subtract 1/3, and we're at 1 2/3. For the interval, we didn't go left or right. So for right now, we're going to be starting at 0, and we're going to be increasing by 1/8 each movement we make. So as we move, we go up 1/8, up another eighth, another eighth, and another eighth to get all 5 of my values. Take those and let's put together our picture for this. And we've got a point here at, for its cosine, we're going to be up here, down here, back to the middle, and then we're going to be here and then here. And what happens is our curve, oh boy, that was a terrible line. Our curve ends up looking like this. Okay. And then if I looked at the critical points for this, you can see we go 0 and then 2 and 1/3. That's that first spot that's right here. And then for the next one, we go pi over 8, 2. So I'm going to go right pi over 8 and then to 2 right here. Okay. And then I'll continue going to the right pi over 4, and I go down to 1 2/3, and so on and so forth. Okay. All right, so let's get to the challenging questions. These are challenging because these are going to require a little bit of work. Now, before I start on these, I want you to remember, we talked about how the b value here has to be pulled out from the x. So if we ever have a number attached to the x, you got to pull it out to the front by factoring it out. And we're going to see that happen here in this third example. You see right here how it says y is equal to the cosine of 4 times x minus pi? Well, that's not in that form that we're looking for, where it's going to be a b value times x minus your c value. It's not currently in that form. So we have to get it into that form. And in order to do that, we have to take this 4 that's right here and factor that out. So if I take a 4 out, what would this look like? Well, basically what we're going to do is I'm going to take this 4x minus pi. And in order to factor out, we're going to take this 4. I have to divide each of these by 4. That factors that 4 out from there. And we're going to be left with x minus pi over 4. So that's how we get it into the correct factored form there. We are taking out a 4, so we're dividing both of those values by 4. And then if I was to go back and check it, I can go 4 times x and 4 times negative pi over 4, and that gets me right back to this value here. So knowing that that is the now factored form of the inside, my graph now says cosine of 4 times x minus pi over 4. So this says we've got a horizontal shrink of 1/4 taking place, and my graph is going to shift to the right pi over 4. It doesn't shift to the right pi. All right, so let's go ahead and look at all these parts here. Ready? Vertical shift, it doesn't go up or down, so there's none. The amplitude is equal to a 1 because there's a 1 right here. Okay. The horizontal shift, we have a 4 here, so that means the c value is going to equal to, I'm sorry, wrong thing. I'm talking about the b value there. The c value for the horizontal shift is that's to the right pi over 4. Okay. And for the period, we've got a 4 here, so we're going to go ahead and say the b value is 4. So we go ahead and do 2 pi divided by 4, which means the period now is again pi over 2, like the last problem. We'll break this into 4 separate increments. And so we're going by pi over 8. Now, let's talk about the left side first, because that's the easy part here to handle. We'll deal with this first. My graph has been shifted. When we look at this, it's been shifted vertically 0. So it still is going to start at 0. Okay, because there's no up and down shifts. The amplitude says that it's going to go up 1 in each direction. So we go up 1 here, and that means we end up at 1. And we're going to go down 1 here, and we're going to end up at a negative 1. For the shift right and left, normally we would start at 0 here, but we have a horizontal shift that takes place. My graph is shifted to the right pi over 4. So that means instead of this being at a 0 right here, we have to take this and we have to actually go to the right pi over 4. That means I'm not starting at 0. I'm going to start at pi over 4. And the incremental increase from here is that I'm going to be increasing by pi over 8. So I'm going to do 1/4. Oops. I'm going to go 1/4 on my calculator. I'm going to add 1/8, and I'm going to add 1/8, and I'm going to add 1/8, and I'm going to keep doing this, just knowing that pi is still going to be attached to each one of these answers. So let's look at the actual graph now for this, now that we've taken care of everything. The C value, I'm sorry, the picture for this is a cosine, which means my graph is going to have a point here, 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 down at the bottom there, and then here, back at the top, okay? And so when we look at this, this is what our curve is going to end up looking like. We'll go ahead and put together those, and there's no reflections in this, so we don't have to worry about any reflections. Let's go ahead and put those values into our critical points. We end up with pi over 4, 1, 3 pi over 8, 0, pi over 2, -1, 5 pi over 8, 0, and then 3 pi over 4, 1. All right, a couple more examples doing this where we're going to be factoring out. All right, let's tackle this here. We've got, in this case, a 2 attached to it, which means we have to take that 2 and factor it out. So again, to go through and do this, if we had a 2x minus pi over 3, and I got to take that 2 out of there, that means I have to divide each of these by 2. That one's kind of hard to see because it's in the same color. I'm going to change the color here. So I've got to divide this by 2, and I've got to divide this by 2. And so what ends up happening is we have an x for the first part. Pi over 3 divided by 2, remember, is like saying pi over 3 divided by 2, which is pi over 3 times 1 over 2, which makes it a pi over 6. So this would become minus pi over 6. Okay? So there's the correct form for this function. I added a minus on accident. Sorry, it's a plus. But there's the correct form. So now we could talk about each one of the parts here. We've got a horizontal shrink by 1/2, and we've got a phase shift to the left pi over 6. So there's no up and down shifting. The amplitude for this is still a 1 because there's a 1 in front of the sign right here. Okay. The horizontal shift is that this is going to go left pi over 6. And it's going to be left pi over 6, as we said. And then for the period, the b value in this is equal to 2. So we're going to have 2 pi divided by 2, which means now my period is pi. So instead of taking 2 pi, it's half of it. Okay. The interval, we're going to break this into 4 equal parts. So take that pi and break it into 4 equal parts. And let's go ahead and do our graph. So we look at the graph, and it has not shifted up or down at all. So because it hasn't, this is still going to start at 0. The amplitude for this is 1 up and 1 down. So I'm going to be at 1 and -1. My graph has shifted to the left. Left pi over 6. So instead of us starting at 0, we're going to go to the left pi over 6, which means we're going to be at negative pi over 6. And we're going to be increasing by pi over 4 repeatedly to get my 5 values. And then let's go ahead and do the graph here. So to do the graph, it is a sine curve. So we've got a point here, 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 and then back here. So we got the curve that looks like this. And then you guys can figure out those 5 critical points. All right. Let's move on to the next one. Some of these are a little bit of a doozy. We're going to start putting together all the transformations into one problem here, but it's the same process over and over. All right. So we're going to start with that b value that's in here. We have to factor that out because that can't be attached to the x. So we'll factor that out. So that means if I look at this, I've got a half x plus pi over 3. Okay. I cannot have that half there. So I have to pull this out to make it a 1/2 in the front. And when I pull that half out, what's going to happen is we're going to divide this by 1/2, and we're going to divide that 1/3 by 1/2 as well. And what's going to happen is we're going to have an x for that first value, but then we have pi over 3 divided by 1/2. That's what we're doing there. We're dividing by 1/2, right? Well, that division turns into multiplication. We take the reciprocal, so that pi over 3 times 2 over 1 means that this is going to become plus 2 pi over 3, okay, with a half in front of that. So now this is the correct form here. We've got that -3 sine 1/2 x plus 2 pi over 3, and then plus 1. We've got everything in this problem. Let's turn it up and let's do it. We're going to eat this up and leave no crumbs. All right, so the vertical shift that takes place, the vertical shift, sound like I said something else there. Right here absolute value of this, that vertical shift means it's going to vertically stretch by 3. Why did I say, oh, shift. Jeez. I'm talking about the amplitude again, sorry. The vertical shift is that this one goes up 1. Okay, so that's the D value, it goes up 1. The amplitude for this is that we have a 3 here, so it's going to get vertically stretched by 3. Okay. The horizontal shift is that B value, and since there's a half, the B value is going to equal 1. Nope, I did it again. That's the period. Sorry. The horizontal shift for this is that it goes to the left 2 pi over 3. I'm so tired. I'm sorry. All right, so it goes left 2 pi over 3. The period now, talking about the B value, is this 1/2. And what we're going to do is we're going to take that B value 1/2 and we're going to go 2 pi divided by 1/2. And what happens is we end up with 4 pi. That should make sense because it's the reciprocal effect, right? If we have a half, the reciprocal becomes a 2. So we're doubling the period that it takes place. If we take that and break that into 4 increments, we're going to have 4 pi divided by 4. So we're going to be increasing by pi. And here we go. We are ready to tackle this. The only thing that did not get mentioned in here is that negative. It causes that reflection over the x-axis, which we'll deal with in a moment. All right, let's throw all of our values in and get moving here. So first off, we took our graph, and because our graph has shifted up 1, we're not going to be at 0 anymore. We're going to shift up 1 to a positive 1. The amplitude for this says that we're going to be going 3 up and 3 down. So we're going to go 3 up to get me to 4, and 3 down from here to get me to -2. Okay. My graph has been shifted to the left. Instead of us being at 0 right here, it's shifted to the left 2 pi over 3. And so instead of being at 0, we're going to be at -2 pi over 3 for the starting point. We're going to incrementally increase by pi, which will give me a 1/3, 4 pi over 3, 7 pi over 3s, and then 10 pi over 3s. For the graph, now we're ready to do this. It is a sine curve, which means we have a point here, 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 and here. However, we have a reflection taking place. Each one of these points has to be reflected over my x-axis. So that means this point right here, it reflects. Well, it's on the x-axis, it won't move. This point here is going to reflect over to this side to be down here. So we've got these points here. This point in the middle is going to reflect, which it's not going to move. This point right here is going to move up to the other side, which means it's going to be up here. And then this point right here in the middle is going to stay because it's not going to move. So the end of game picture here is going to be, we're going to have a point here, 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 and here. And now this is what our graph looks like. Voila, we've got everything taken care of here now. All right. And then my critical points, you can go in and write those in. You guys are good at these at this point. All right, we have one more question we're going to do here, practicing taking out everything. Whoopsie doodle, showed that value a little too soon. All right, so let's practice again with factoring out this b value that's right here. So if I have a 3x plus pi over 4, and I have to factor out that 3 that's right there, got to factor this out. We're going to have a 3. And when I do this, we're going to divide everything by 3 to factor that out. What will happen is we're going to be with an x, and that pi over 4 divided by 3 is going to turn into pi over 4 times 1 over 3. So we just end up with a pi over 12. Okay? The final picture or equation is going to be 1/3 cosine 3 x plus pi over 12 minus 2. Let's go through each part. I'm going to get it right this time. I am ready. I am not going to screw this one up. The vertical shift is that this one is going down 2. So my d value for this is -2, and it's going down 2. The amplitude for this is right here of 1/3. So that's my a value is 1/3. So it's a vertical shrink by 1/3. The horizontal shift here is that it's going to move left pi over 12. The c value is negative pi over 12. And then it's going to go left pi over 12. The period for this has a 3, which means my b value is 3. And so we're going to take our 2 pi and divide it by 3. We're going to take this 2 pi over 3 and we're going to break it into 4 separate increments, which means we're going to have 2 pi over 3 divided by 4, which is now 2 pi over 12, or we're going to be going incrementally by pi over 6. To make this picture, I already left the cosine graph up there because it's a cosine. It's not reflected in any way on this problem, so I just drew it. Let's go through the parts here. Since my graph was shifted and we took it and we moved it down 2, this value is going to be a -2 since we moved down 2. The amplitude is 1/3 up, okay? And then we're going to go from there. -2 plus 1/3 will put me in -1 2/3. And if I go 1/3 down from there, that's going to put me at -2 1/3. For my starting position, I went ahead and I moved it left pi over 2. So instead of us being at 0, we are moving it left pi over 12, right? And so that means we're starting at -pi over 12. We're going to go ahead and increase by pi over 6 for the increments. And then our critical points are just these 5 critical points here, okay? So as you can see, it's pretty repetitious, the behavior of how to actually handle all these. It's just a couple of different steps to work through. But they're little details. Just the only thing that people usually screw up in these is the factoring out of our B value. That's usually the hardest part. So make sure you're comfortable with that. If you're not, reach out. Let me know. I can help you further. But otherwise, as always, I believe in you. You got this. You guys take care. Be safe. Be respectful. Be responsible. Don't forget to like and subscribe to my channel. And have a wonderful day.